All right, here's homework 5 on section 5.5. Problem number 5 is 5 factorial, so these are going to be real quick. 5 factorial is, 5 times 4 times 3 times 2 times 1. Number 6, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. The answers are right there in the blue, of course. Number 19, 8C3. This is taking 8 things, choosing them 3 at a time, and order doesn't make a difference. In other words, if you choose A, B, C, and B, A, C, those would be considered the same arrangement. And so that we would just do on our calculators, and we would get 56. And for 20, we 9 choose 2. We would get 36 for that. Now, we talked about this in class, although I'm not requiring you to know this for this class. This really is 9 factorial over 9 minus 2 factorial times 2 factorial. Okay, and if you work that out, you get 36, but we get to use our technology for this in this course. All right, 21 is same thing. 10 choose 2 is take 10 things. We're going to select 2 of them, and order doesn't matter. Okay, and 31. Okay, 31. We've got the man has 6 shirts and 4 ties, assuming they all match. How many different shirt and tie combinations can they wear? Well, I'd like to think of it like this. He's got how many options for shirts and how many options for ties. He's got 6 shirts, and he can wear 4 ties with it. And he's got, so it's going to be, well, it's right, 6 times 4 is 24. So you can think of it like this if you want to visualize it. Suppose he wears shirt number 1, then he's got 1, 2, 3, 4 ties. Shirt number 2, 1, 2, 3, 4. Shirt number 3, 1, 2, 3, 4. So how many 4s is he going to have? Well, how many shirts does he have? 6 times 4 is 24. Okay. All right, 49. The art exists where balls are numbered 1 to 25 are placed in an urn. To win, you must match the 4 balls chosen in the correct order. That's key right there. How many outcomes are there for this game? Well, you're going to match 4, so there's 4 balls in the correct order. So you have 25 choices for the first ball, 24 for the second, 23 for the third, and 22 for the fourth. It's not combinations because a different order is a different arrangement. So we have to think of it differently. So when you multiply those together, you get 303,600. Okay. And number 50. That was 49, by the way. 50. In the U.S. Senate, there are 21 members of a committee. We want to select 9 of them to be on a subcommittee. Okay, how many different committee structures are possible? Well, we've got 21, and we're going to choose 9 of them. And the reason I can do combinations and not 21 times 20 times 19, if you do it this way, this tells me that committee with person A, B, C is different than committee C, A, B. But in a committee, these 2 groups are the same, so I don't want to do that. This one right here, this one divides out the repetitions. So this is 21C9, and if I do that on my calculator, let's get this over here on the side. 9 is, wow, 293,930. Okay, different subcommittees you can have if you take 21 people and choose 9 of them. All right, let's leave this one at that, and we'll do the next 2 on the next video.